Good morning, students. This is Charan sir, Department of Statistics. So today's class, we are going to solve few more problems based on bivariate frequency distribution, right? So yesterday we could complete only one problem from bivariate. So today, two more problems we shall see in this video. Okay, and just before going to start the problem, I would like to give you the brief idea about what we have solved yesterday. For example, in the yesterday's problem, ages of mothers and number of children. The problem we have calculated yesterday on the board. Right, there different ages of mothers and number of children according to that age. We have framed bivariate distribution table. See, as I mentioned, in the question, if it is mentioned that what is the width, we have to frame, and then what type of class interval like exclusive or inclusive, if they had asked such cases, we need not apply Struth's rule, I can say k equals to 1 plus 3.322 log n. Only when to apply this Struth's rule? Only in case of alone raw data is given in the question. So if only raw data is given, for finding the number of classes, we use k, 1 plus 3.322 log n. Am I clear? So now, even this data, just they have asked us to prepare a bivariate frequency table, and the raw data is given individually, two different variables, marks in max and marks in stats. Right. So bivariate means what? Which deals with two variables. Right. That is what we have discussed yesterday. Concentrates on two variables. That itself is the bivariate. Clear? So now, a frequency distribution formed on the basis of two variables is called as bivariate frequency table. That is what yesterday I have given you the definition on the board. Now today, problem number 2, prepare a bivariate frequency table considering two variables, marks in max, marks in stats. Okay, first let us consider, here everything is unknown, right? We don't know width, and we don't know how many classes are to be framed and what type of class interval should be formed. So nothing is known. Then in such case, we have to use Struth's rule, k equals to 1 plus 3.322 log n, for finding the number of classes. If you know the number of classes, just by calculating range, we can find out the width, that is equals to range by number of classes. This is how the bivariate frequency distribution table has to be formed. Now let us see this problem now. Raw data is given, marks in max and marks in statistics. Let us see this problem. First and foremost, what we need to calculate? Range. Before that, let x be the marks in mathematics and y be the marks in statistics. Let us consider two variables. This is x and this is x variable, and this is variable y. So let us consider both the variables x and y. Now bifurcate into two. Okay, x and y. Calculate step by step. Here step 1, finding range. You all know that range is highest minus lowest. Now among x variable, that means marks in max, which is the highest value, you just verify. According to me, the highest value 65, here 72. So 72 is the highest one. Minus, which is the lowest value, 30, 25. So 25 is the lowest value. So 25 plus 22, 47. So the range from x variable is 47. Here range from y. Now check out the y variables, which is the highest value. 85. 85 is the highest one, and lowest value is 10. 10 is the lowest. So there in y variable range is 75. Next, step 2. K equals to 1 plus 3.322 log n. So 1 plus 3.322 log 22. So number of classes finding is common in both the sides. Next, what is log 22 value? Log 22. 1 plus 3.322. 1 point. How much log 22? Log 22 value is 3424. 1.3424. Now, by multiplying both, what is the value? 1 plus 3.322 into 1.3424. Let us see the calculation later. And then width equals to range by number of classes. Even here also, width equals to range by number of classes. Now, here also the same number of classes will appear, because the total number of observations here also 22 and here also 22. So number of classes finding remains same for both the variables. Only range and width will differ. Now just wait for 1 minute. So I will be calculating this one number of classes. 1 plus 3.322 into 1.3424. Log 22 is 1.3424 value, and number of classes calculation would become same for both the variables, because here total number of observations are same in both the variables x and y. Yes, look at here now. 3.322 into 1.3424 plus 1. So here you will be getting 5.45, approximately 5 classes. Even here also 5 classes. Now calculate the width. 47 divided by 5. 9.4, approximately 9 classes, 9 width, and here width equals to range by k, that is 75 by 5, 15. Right? Now frame the table. Data we have got. Now we have to frame the table. Y. Now here the least value is 25, highest value is 72. Now within 5 classes it has to be framed by taking the width 9. So we'll do one thing. Here 5.459 approximately it will be 647 by 9. So let it be this one. Now frame it now. X variables. Start from 25. So 25 to taking 9 is the width. Within 6 classes, within 5 classes it has to be framed. So 25 to 9 means 25, 26, 27, 28, 29, 30, 31, 32, 34. Now 35 to again 5. 44. 45 to 54. 55 to 64. 65 to 74. 1, 2, 3, 4, 5. Within 5 classes. Next, Y variable. Here least is 10. With class width 15 up to 85. 10 to 15. 25. Next 25 to 40, 40 to 55, 55 to 70, 70 to 85. So the total is, now one by one check the tally. 53 marks in maths, 58 marks in stats. So 53 lies here and marks in statistics 58. These are marks in statistics. These are marks in maths. Now first observation 53, 58. 53 and 58. So here one tally. 53 and 58 together, one tally. Here and here. And next one 54, 55. 54 and 55. Here. And then 52, 25. 52, 25. Here one tally. 32, 32. 32, 32. Here one tally. And then 30, 20. 30, 20. Here one tally. 60, 85. 60, 85. Here one tally. And then 47, 44. 47, 44. Here one tally. 46, 80. 46 and 80 from here. Here one tally. And 35, 33. 35 here, 33 here. One tally. And then 28, 72. 28, 72. Here one tally. Next 25, 10. 25, 10. Here one tally. And then 42, 42. 42, 42. Here one tally. Next 33, 15. 33, 15. Here one tally. Next 48, 46. 48, 46. Here one tally. Next 72, 50. 72 and 50. Here one tally. 51, 64. 51 and 64 lies here. Here one tally. And then 45, 39. 45, 39. 45 and 39. Here. 45 and 39. one slight change. This we can make it as 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Make it this also class 12, 25 to 39, 40 to 54, 55 to 69, 70 to 25, 25 to 40, 40 to 55, 55 to 70, next 51, 64, 51, 64, here one tally, 45, 39, 45 and 39, here one tally, 33, 33, 33 here and 33 here one. Next 65, 30, 65, 30, here one tally, 29, 36, 29, 36, here one tally, 35, 40, 35 and 40, here one tally, 40, 52, 40, 52, here one tally. Now write down the total. Here 3, 3, 6 plus 1, 7. Next 3 plus 1, 4. 3 plus 2, 5, 5 plus 4, 9, 10. Here 1, here 2. Then tell me the total. 10, 11, 18. How many total? So somewhere the value is repeated, I suppose. First observation. So we shall do once again all the tallies. So there one value I have repeated. Once again we shall check the tallies over there. Fine. So pardon me, there one in between it got interrupted because of calculator and all. So let us just do once again the tallies from the beginning. So 53, 58. Here 53 and here 58. Check here 53 where it lies here. 53 and then 58 here. So here one tally. Next, second mark in max 54 and second mark in stats 55. 54 here and 55 here. Tally number 2. Next, 52, 25. 52 here and 25 here. Here one tally. Next, 32, 32. 32, 32. Here one tally. Next 30, 20. 30, 20. Here one tally. Next 60, 85. 60 and 85. Here one tally. Next 47, 44. 47, 44. Here one tally. 46, 80. 46 and 80. Here one tally. 35, 33. 35, 33. Here one tally. 28, 72. 28 and 72. Here one tally. 25, 10. 25, 10. Here one tally. 58, 42, 42. 42, 42. Here one tally. 33, 15. 33, 15. Here one tally. Next 48, 46. 48 and 46. Here one tally. 72, 50. 72 and 50. Here one tally. 51, 64. 51 and 64. Here one tab. Next 45, 39. 45, 39. Here one tab. 33, 33. 33 and 33. Here one tab. 65, 30. 65 and 30. Here one tab. 29, 36. 29 and 36. Here one tab. 35, 40. 35 and 40. Here one tab. 40, 52. 40, 52. Here one tab. Now calculate the total. 3 plus 3, 6, 7. 3 plus 1, 4. 2, 2, 4, 7, 8. 1, 2. Now here the total, column total. Now this is marginal function of x and this is marginal function of y. Now here the total is 3, 4, 5, 6, 7, 3, 2, 5, 6. Here only 3, here only 3. Now together the ultimate total is 7 plus 4, 11, 19, 20, 22. Now here 3 plus 7, 10, 16, 19, 22. So this total and this total both should get tallied. Clear? Now this is a problem, bivariate frequency distribution problem. Now if at all asked marginal distribution of x, what do you need to write marginal distribution of x? 25 to 34, 35 to 44, 45 to 54, 55 to 64, 65 to 74. For this, what are the totals? 7, 4, 8, 1 and 2. Now this is the marginal function of class interval and frequencies. Marginal function of x. Similarly, marginal function of y. Marginal distribution of y. What are those? 10 to 25, 25 to 40, 40 to 55, 55 to 70, 70 to 85. Now, those frequencies 3, 7, 6, 3 and 3. This total is 22 and this total is also 22. This is how the bivariate distribution problem has to be calculated. Once again you see the problem, complete problem. Okay, so prepare a bivariate frequency table. Data marks in max, marks in stats. First let us consider x be the marks in max and y be the marks in stats. Now here we don't know the width and we don't know how many classes are to be framed in the table, right? In such cases what we have to apply? Look at those steps. First, range we need to calculate from both the variables x and y, as well as Strutt's rule, because everything is unknown. We don't know the width as well as type of class interval. So that is the reason we have to calculate using Strutt's rule. K equals to 1 plus 3.322 log n. So you'll be getting the approximate value of 5, and the width is also there. Range by number of classes. So 47 by 6, 9.4, approximately 9 should be the width within 5 classes. Even variable y among 5 classes with taking width 15, it should be framed. Clear? So after that, take the table, and then always, as I said, one of the principle of classification, multiple of 5 it should be the lower limit whenever the class interval starts. Multiple of 5. So see there, 25 to 34, 35 to 44, 45 to 54 there, and the y variable 10 to 25, 25 to 40. So this way we have taken it. At the same time, even exclusive type of class interval also can be taken. 25 to 34 is there, no, up to 35 can be taken. Now again 35 to 44. So this one can be taken as exclusive type also. 25 to 35, 35 to 45, 45 to 55, 55 to 65, 65 to 75. So exclusive type of class interval we have taken there. According to that, we calculated that one. Even marginal function of x, change this. 25 to 35. Anyhow, this 35 is not included here. This 35 is included here because exclusive type of class interval, the upper limit is excluded and included in the next class. Anyhow, while putting the tallies, we have done the same. Only the exclusive type to make the same. Both x and y exclusive type. 35 to 45, 45 to 55, 55 to 65, 65 to 75. So that is the marginal function, marginal distribution of x and y. So this is the problem, bivariate frequency distribution problem. So once again you have a look. Tallies, be very cautious. See, just now while observing side by side only, I got little confused, and then one value, one tally has gone wrong. Entire problem tallies have gone wrong. So it shouldn't be like that. So carefully observe. One value from x, one value from y. Together parallelly we have to, perpendicularly we have to join, and then there one tally should be taken. Remember. So perpendicularly it should be one from the row and one from the column. So where it exactly joins according to the number observation given, first in max and first in stats. Similarly, second in max and second in stat. Third in max and third in stats. All together 22nd person marks in max and 22nd person marks in stats. Together perpendicularly we have to put the tallies. Then we will be getting the frequencies. Now marginal distribution of x means these all x and those frequencies. These frequencies are marginal distribution frequency of x frequencies and class intervals. These are class intervals and y frequencies. So the same way I have written on top. Once you observe these two, marginal distribution of x and marginal distribution of y. So this is how the bivariate problem has to be calculated. So one more problem we are going to solve. So clearly you observe the problem now once again. See here, x and y variables both should be taken exclusive or should be taken inclusive, preferably exclusive type of class interval, as I mentioned, one of the principle of classification. Okay, do you remember all the principles? Type of class interval, I mean exclusive or inclusive, preferably exclusive type for the better continuity of the interval. We have to take exclusive type, and width should be the same of all the intervals, classes. So look at there, all the widths are same. Right, y variable all the way, y variable all the class intervals width is same, and x variable all the class intervals width is same, and it should be framed, the classes should be framed between 4 and 15. It is 5 observations we have fixed, so 4 and 15 in between only should be taken number of classes. And then we have to avoid open-end classes. If you are taking, it should be either in the beginning or it should be at the end. The open-end class must be, remember. So preferably avoid open-end classes. Maximum you try to frame the value, or else the same way as I said, that at the initial stage or at the end stage open-end classes should be taken depending upon the data. Preferably at the end stage only, above should be taken. And one more thing is that the lower limit should always be followed multiple of 5. Remember, class interval, the lower limit of the class interval must be a multiple of 5. So with all these conditions, we are framing a continuous bivariate frequency distribution table. So I hope I am clear this problem. Carefully you must draw the tallies, as well as unless and until they ask marginal distribution, you need not write. If they ask, write down the marginal distribution of x, then only you are supposed to write after framing the bivariate table. Clear? So we shall start the next problem in the next video. Fine? Thank you.